สวัสดีครับวันนี้ผมจะพาทุกท่านไปเยี่ยมชมการซ่อมบำรุงรถไฟความเร็วสูงกันนะครับแต่แน่นอนว่าในประเทศของเรายังไม่มีรถไฟความเร็วสูงวิ่งให้บริการดังนั้นก็จึงไม่มีสถานที่เพื่อให้เราไปเยี่ยมชมได้ภายในประเทศนะครับแต่ก็โชคดีที่สถานีโทรทัศน์ NHK นะครับได้เคยถ่ายทำสารคดีเกี่ยวกับการซ่อมรถไฟความเร็วสูงของประเทศญี่ปุ่นเอาไว้นะครับดังนั้นผมจึงขออนุญาตท่านนะครับไปชมการซ่อมบำรุงผ่านคลิปวิดีโอนี้นะครับไปชมกันเลยครับ
In the suburbs of Sendai, in Miyagi Prefecture, you can find the Shinkansen General Rolling Stock Center of the East Japan Railway Company. Covering an area equal to 70 football fields, it is the maintenance and inspection facility for the Shinkansen. It handles 6 different types of train car, 1,200 cars in total. This is the E5 series. Next year, E5s will run at a top speed of 320 kilometers an hour. The E5 also offers a new class of service. Called Grand Class, it is a step above the green car and is modeled after first class in the airline industry. Grand Class cars will have wool carpeting and reclining seats to make the trip relaxing. Japan's bullet trains run like clockwork. Let's see the maintenance regime that makes that possible. There are 4 levels of inspection and maintenance. First, the inspection conducted every other day. The wheels, brakes, and pantograph are given a visual inspection. This is what a pantograph looks like as a train runs at speed. It supplies 25,000 volts of electricity to the train from overhead wires. After confirming that the power is off, a worker goes onto the roof of the train. This is an overhead line, a copper wire 15 millimeters in diameter. If the pantograph does not have correct spring pressure to hold it firmly in contact with the wire, the train cannot run properly. By looking at the grooves worn into the pantograph, workers can tell whether it is making contact properly. If they are even, the pantograph is okay. If there is unevenness in the wear, the train cannot carry passengers until the problem is identified and corrected. These inspections are performed mainly in the middle of the night, after the trains have stopped running. Once a month, a regular inspection is held. Parts subject to friction are replaced, and areas not easily seen from the outside are carefully inspected. For example, this shaft is being tested for any damage or cracking. Designers are always striving to make trains lighter. The shafts are actually hollow inside. This allows a device to be inserted to detect whether any cracks are present. Without having to remove the wheel, an ultrasound scanner can be inserted into the middle. About 40 years ago, an accident occurred when a shaft broke because an electric outage during its manufacture had caused a flaw. Painstaking inspections like this are to ensure that type of accident is never repeated. The third stage is the bogie inspection, conducted every 18 months. The bogies are a critical component of the train. They are disassembled and given a complete overhaul. To do this, first the chassis is lifted off the bogies. Four workers are assigned to each car. They perform a series of tasks in a set sequence. This is a bogie that is being disassembled for the first time in 18 months. First, the wheels undergo maintenance. This is what the wheels look like before servicing. They have run approximately 600,000 kilometers since the last maintenance. Now their surface will be aligned. As a wheel rolls along a track, the surface is gradually worn away, changing its shape. If this wear proceeds too far, it causes vibration, leading to degradation of the train's design safety and performance. So the surface of the wheel is machined down to restore the correct profile. On this occasion, 2.5 millimeters of material are machined away, turning an 850 millimeter diameter wheel into an 845 millimeter diameter wheel. Here is a reprofiled wheel. This machining must be performed to exactly the same dimensions on every wheel of the train. If there is the slightest deviation in diameter between the wheels on each side, ride quality and safety are compromised. So every wheel is correctly sized to an accuracy of 0.2 millimeters. After machining, its dimensions are measured. This scale measures hundredths of a millimeter. The right wheel is measured at 845.24 millimeters. The left wheel is measured at 845.28 millimeters. The difference is just 0.04 millimeters. Commitment to this level of precision, down to the hundredths of a millimeter, is what makes the Shinkansen so safe. The fourth stage is the general inspection, performed at 1.2 million kilometer intervals, about every 3 years. Not only the bogies and wheels, but the instruments and even the passenger seats are disassembled, inspected, and overhauled. The general inspection includes a complete repainting, and afterwards, the train car returns to service as a practically brand new car.